Development Manager for Aberdeen Renewable Energy Group, or AREG. And as a background for AREG, for those who aren't members, who aren't aware of exactly what we do, we are a not-for-profit membership organisation based in Aberdeen, focused on accelerating the energy transition and supporting our network of members across the supply chain and supporting industries to advance the energy transition all across Scotland, the UK, and globally as well. So this is a quick snapshot of some of our members. We have over 270, so surprisingly can't fit them all on one screen. But I'm sure some of you will recognise your own organisations there. But if anyone would like to have a catch up on membership, touch base with any of the team, please feel free to reach out, and we're always happy to catch up with our members. And if anyone who isn't a member would like to learn a little bit more about membership, please also do reach out. You can contact us at info@Aberdeen Renewables, message us on LinkedIn, or catch us at events or anything like that as well. Just some exciting things coming up. So next week we are hosting the Scottish Energy Futures Conference. It's a partnership conference with SPE Aberdeen. So our last chance for tickets, so please do get involved and sign up if you are interested. I'm sure a lot of you will already be signed up, potentially presenting, speaking, anything like that. But if anyone has any questions, please do feel free to reach out. Just some of the highlights for the conference, some of the key speakers, including Lord Nicholas Stephen from Flotation Energy. We will also have Alan McCaskill from Flotation, who will be supporting one of our panel sessions. So if anyone wants to learn a little bit more or touch base with some more of the team from Flotation, I'm sure you'll get a chance to do that at the conference as well. Sarah Knight from Crown Estate Scotland, Maggie McGinley from Energy Transitions Unlimited, Russell Dawes from NZTC, and many, many more. So please do get involved with the conference. Reach out if you're interested in either attending, exhibiting, anything like that. If anyone's got any questions, please do get involved. That's a little brief overview of some of the panel sessions that we'll have, but it's going to be a really exciting couple of days, so please do reach out if you've got any questions. Little link to get registered. I'll share the slides at the end again as well, just if anyone has any questions, please do reach out. So that's all from me just now. I'll pass along to our fantastic speakers from Flotation. We have both Alex and Tim, who will give an overview of the projects they have going on just now, and a little bit of an insight into the technology that Flotation are developing and advancing in the floating offshore wind industry. So I will stop sharing my screen and pass along to the main man of the day, and please do get involved with the Q&A, and we'll be able to share the slides and everything after as well.
Thanks, Sarah. I think hopefully you can all hear us. Okay. Thank you, everybody, for taking the time today to join this webinar. We do hope it's of interest. I guess it might be worth Tim and myself just briefly doing a quick introduction of ourselves, and then we'd love to tell you a little bit about what Flotation Energy is doing and what we see as some of the key opportunities for particularly floating offshore wind in the UK going forward. So a little bit about myself, just briefly, and then I'll maybe ask Tim if you'd do the same. So I'm an engineer by training. My research in engineering was originally into aircraft design, acoustics, and signal processing, but I got into BP about 15 years ago now, and started working on low carbon technologies, low carbon carbon sequestration. And then led off into major projects and looking at roles for renewables within those, as well as doing some, I'm afraid, oil and gas engineering as well along the way. And I worked a lot on the use of technology across the whole business, including looking at how low carbon technologies could help us as a company. About 4 years ago, I became aware of the work being done by the principals of Flotation, Alan McCaskill and Nicholas Stephen, as they look to really kick Flotation Energy, a company that they'd started fairly recently, into high gear and launch new projects and new opportunities. So I joined the company 4 years ago, and for much of that time, I led our what we called in the end INTOG projects, Greenvolt and Senos, looking at opportunities for floating wind to decarbonize the North Sea energy assets that are out there today. Obviously, an area that we've been very successful in as a company now, with both the Greenvolt and Senos projects firmly up and running. Greenvolt's running quite a bit faster these days, and it's now secured, obviously, its CFD and off into feed, as we'll discuss in this talk. And the Senos project's running a bit behind that, but still presents an immense opportunity to scale floating offshore wind, as we'll discuss today. So that's my background. I don't know, Tim, if you might do the same briefly.
Yeah, sure. Good afternoon, everyone. I'm Tim. I'm one of the technical authorities in Flotation Energy. My job title is Floating Systems Technical Authority. So in reality, that means I look after the hull and the moorings and the interface with the turbine. My background is I'm really a moorings person, and I was fortunate or misfortunate enough to be involved in floating wind since about 2014, or about one form or another. Originally in mooring equipment supply and a lot of opportunity development, but also looking at some of the early technologies and so on. And then prior to joining flotation, I worked in SSE renewables in a kind of similar role as I do in flotation. I think it's notable, as Alex kind of alluded to, that I think flotation is in an extremely enviable position of having a pretty dynamic portfolio of floating wind projects. So, the reason I mentioned that in the context of my role and what we're going to talk about today is that many of what you will see published and spoken about in floating wind is hypothesis and conjecture. I think for good or for bad, we're in a position, and in fact, my kind of bread and butter in my role is trying to develop realistic strategies to actually execute floating wind projects. And hopefully, in the next hour or the next 50 minutes, now we can share some of that insight with you.
That's great, Tim. Thanks very much. So I guess we have a presentation. We expect the presentation to last probably about 20-30 minutes. And then I think we'll hopefully be able to take some questions at the end. So I'll kick off. In the event that there's a catastrophe with AV and I don't realize and I'm talking to myself, I'm sure someone will phone me up and let me know. I'm looking at Tim and Sarah there. Okay, good. Then without further ado, here we go. So yeah, a little bit of reverse introduction, I guess, just reintroducing Flotation Energy. So Flotation was founded in 2018 with the previous team having experience of both the Beatrice fixed offshore wind project, which at the time was the deepest fixed project, the world's deepest, I think, and furthest offshore at the time. I'm not sure, but it was part of a piece of work to electrify the Beatrice oil and gas platform. And in many ways, it was quite successful because I think it allowed the additional power allowed Beatrice to make its operations topsides much more efficient, and hence continue to operate rather than scrapping the asset for some time. What that also did was take a leap forward in the world of jackets and offshore wind as it was back then. Kincardine, obviously, everybody on the call I think will be aware of, and there's a couple of pictures of it here. Our principals were involved in were central, really conceived the idea of the Kincardine floating wind project and took it all the way through to execution, and it's now up and running. It's been generating, I think, for 6-7 years. I think in its current state about 5. So really pioneering assets, not just in the UK but globally, both projects. So Flotation Energy really trying to take that opportunity a stage further, and I think we're doing a fantastic job at that. Our initial success was actually with the Morecambe project in 2021, securing the round 4 lease. At the time, the market was incredible for offshore wind of any type, and it was a huge success for us to be able to capture that. I joined the company right around the time that was the success was announced. Pretty much, I wasn't involved in the bid, but I was involved in helping to set up the initial part of the project that then followed, and then pioneering the oil and gas decarbonisation space, which I think has been something that we've been passionate about building on that Beatrice experience for many years. And I've been delighted to be part of that journey. Flotation was acquired by Tokyo Electric Power, renewable power in 2022. And that's really given us a huge boost as a company. We were previously obviously a startup, and that's enabled us to take on projects of the scale of Greenvolt, Senos, and others. So a really exciting journey for us as a company. This is our UK portfolio today. So Greenvolt is sitting right at the front there, and we'll talk a little bit about more about Greenvolt during the call. But we also have a pretty exciting test and demonstrator project, Whitecross, which is in the Celtic Sea, for those not familiar, and really at an exciting stage in its own right. And of course, there's very little down there in terms of offshore wind today. So really an exciting place for flotation to examine the possibility of floating wind, or the possibilities of floating wind. And then Senos is the kind of sister project for Greenvolt in a way. Also part of a joint venture with Vågrun, which we launched in 2022. And the Senos project really takes floating wind to the next scale again. So Greenvolt is really sort of first commercial scale, sort of 500 megawatts project, and Senos would be that leap into the big time. Floating projects really competing with fixed for capacity, and some really exciting challenges around doing that that we are very keen to progress. So yeah, the main themes here. We are very interested. We're still very interested in electrifying and decarbonising oil and gas platforms, removing offshore generation wherever we can see that it's practical to do it. We have also pioneered within Morecambe the opportunity for shared transmission assets. We know something that the UK is passionate about, and we've actually tied up with BP on that with the Morgan Wind Farm, and that's been a pioneering piece of work as well. So really trying to cut new ice and say, look, why hasn't this been done before? Can we do it? And that's really our modus operandi, if you like. Yeah, so building the team as well has been a key part of that. We continue to grow the team. We continue to seek ways to really push this industry forward. And I would say in more challenging times, as we see at the moment, potentially for some renewable projects globally, that's a really exciting thing to continue to be able to do. We continue to see very exciting portfolio in the future for particularly floating offshore wind. So Greenvolt, just to pick up on Greenvolt and give a little bit more background. So it is designed to support the electrification and decarbonisation of oil and gas facilities. There's a number of oil and gas facilities around it, and the hope is that we will be able to offer power to those facilities and reduce the use or eliminate the use of offshore existing power generation facilities. Those of you connected to oil and gas facilities or who have worked in the oil and gas sector, offshore sector before, will realize how big a challenge that is. You have to be able to offer reliable power. You have to be able to offer competitive power, and you have to be able to integrate with very complex existing assets that are sitting offshore. We were part of the team that really tried to motivate Crown Estate Scotland to launch the Intog leasing round, and we've really developed this from the ground up as a concept, as a company. So very exciting. And Greenvolt obviously now has completed some pretty significant milestones, which are on the next slide, but it's now progressing into the feed stage. So, and there's an image showing where it is, about 80 kilometers. For those who don't know, I presume most people do, off the northeast coast of Peterhead. So what's involved in getting to that stage? In about 2020, we did our first activity on the project, which was nothing to do with engineering, nothing to do with design. It was to look very carefully at available seabed and available sites and see where we could squeeze into, and start doing environmental surveys. and that's what we did. We, huge credit to our principals, took the risk of going out there as a startup company and cracking out in the North Sea, doing aerial surveys for marine habitat and birds and all the things you need to know about when you want to get environmental planning approval for an offshore wind farm. And that meant that within 2022, we were able to pull together all of the final documentation we needed for submission of our planning in the beginning of 2023. And it also put us in a very strong position, a very competitive position in what became the INTOG leasing round in 2022. So a lot of the early days was explaining to regulators how we thought this process could work, and explaining to oil and gas companies how we felt this process could work, and really pushing that very, very hard. And that's what we did. And accumulating in early 23 with winning sites for both projects, capacity of 1.9 gigawatts, which for floating wind is very, very significant, as I previously mentioned. And then early 2024, we were actually able to close out the planning both onshore, offshore, and that enabled us to make an application for a CFD. And I omitted to mention, I should have mentioned that along the journey, we were delighted to welcome the investment in flotation from TEPCO Renewable Power, obviously, acquiring flotation in late 22, but also within the projects, within Greenvolt and Senos, welcoming investment from our partners, Vårgrønn in Norway, who were equally excited by the opportunity presented here. So they are full partners in Greenvolt and Senos now, and continue to develop those projects with us. So anything that we talk about related to Greenvolt and Senos is very much shared endeavour with them here. So in mid 2024, Greenvolt was awarded the CFD, which is transformational to us as an organisation. It's transformational to the project, and it's transformational for floating wind, which is, we think, why the government got behind a significant increase in the pot size for floating wind to enable major projects to come through. Greenvolt's obviously secured a 400 megawatt CFD, which was the capacity we were eligible to apply for, which we were absolutely delighted by, at an attractive price for delivery. So that represents a value of something around £3 billion. So huge investment by ourselves to go alongside that, and a huge opportunity now for floating wind to become real, and become real at commercial scale in the UK first, and to really pioneer that globally. So it couldn't really be more exciting, to be honest. The end of 2024 marked the point at which I handed the project over to a delivery team. So Greenvolt is now sitting with the integrated Greenvolt delivery team, and is on a path to financial close within 2 years, which is really very, very exciting to see a project of that scale. Expecting first power in 2029. So my role now is switching across to the application of technology across the whole business, and that's something I've done quite a lot of within the oil and gas sector, but not so much within flotation, as I've been quite project focused. But I think it's an important point for us, and Tim and I work very closely on how technology is going to change what we've done at pilot scale. Projects like Kincardine, where we needed to demonstrate that we could actually build a thing, that it would turn, that it would generate power, that it would float. All of those things could be ticked off. All of those things go now right up the TRL scale. What needs to be addressed next is how we start to bring that cost down, how we might make it more robust, give it the lifetime that it needs, which is 25 years minimum, and enable it to be operated at commercial scale. So I'll touch on some of the challenges that brings in a moment. But for those, I guess project management 101 here in terms of technology adoption, for those who are aware, I think the most important thing about new technology is you, in a project like Greenvolt, have a pretty limited timeline to make your choices. So we're looking very hard now at what technology do we need to adopt to make the project cost efficient, to make the project constructible within the time frame that we have for the CFD. And, you know, as illustrated on the graph here, the opportunity space for that is very immediate, because as you start to make selection decisions, as you start to progress feed, and you start to tell the contractors what you actually want to buy, how you want to buy it, your options for introducing additional equipment, modifying equipment, introducing sensors, introducing power sources, introducing inspection hatches, whatever it might be that you want to do, those options start to close off, or they become very, very expensive to go back and retrofit. So we're looking very hard across Greenvolt, across Senos, across Whitecross, and looking at the market of technologies that's needed to make a floating wind farm competitive and operable for, you know, decades to come. So very, very exciting challenge, and one I'm sort of digging into across the portfolio now. I guess, you know, just again, back to the basics on technology. Many of you will be familiar with technology readiness level scales. You know, what we're really saying is, and this is something that's not uniquely defined almost in oil and gas or in renewables, but I think the standard that we have to some extent is DNV 203, and that's been helpfully interpreted by the Offshore Wind Innovation Hub here. You know, technology that's been demonstrated in the environment is TRL 6. We really need to be seeing technologies that we want to use at that level or above very quickly now. So that's something we're working incredibly hard on. And the key is to make sure that all the opportunities that we have, many different possibilities that are out there, are funneled and, where appropriate, adopted. And when we adopt something, we need to have the right qualification plan that's going to go with it and deliver it and make sure that it can be integrated, that it will work. Because obviously, if we decide to adopt a technology and then it doesn't work, we'll either have to have a backup option, which carries cost, it carries risk in itself, or we'll have to go back and engineer something else, which, you know, if you're in feed, is just about doable. If you're in construction, is an absolute nightmare. If you're in operations, it's going out and retrofitting things in the field, which we absolutely don't want to do. Some of the challenges that we're looking at then, so as kind of discussed, and this is really looking across elements of the wind farm that you would recognize quite readily, I think, sort of stepping through, you know, sort of building blocks. Greenvolt is currently at that engineering stage. So as I say, we're looking at those key technical decisions. What do we need to do differently at commercial scale for floating wind? And Tim's going to touch on a little bit of that in the next few slides. What can we do to future-proof? You know, if we want to use robotics, if we want to use inspection vehicles, you know, do they need power? Do they need docking stations? You know, what might we want to do about the inspectability of steel we put on the substructures, or the ability to add to replace components? Note the recent replacement of the major component exchange on the Kincardine turbines, where we're able to use up tower cranes to replace major components. Making sure that we've got capacity to do that is a critical part of project design and definition at this stage. So that's something we're very closely focused on today. We're also looking at the challenges around assembly and integration, which will happen at UK ports, and is something that remains a really challenging area, clearly, and Tim will discuss this in some detail. We've never built, you know, we haven't built things at this scale for some time, and really mass production of this kind for large component structures like offshore wind substructures for floating turbines is something that's not been done before. So really challenging in terms of reactivating old industrial sites or creating new industrial sites to make this happen, and it's a central focus for us at the moment. Clearly, we also need to look at how we move these things around, how we're going to store them, how we're going to position them, how we're going to assure them. and maintain them all the way out in the field, 50 kilometers offshore, or 80 kilometers offshore, 50 miles. And that involves looking at really what I call the automation challenge. How are we going to do continuous inspection? How are we going to work on equipment that is sitting out there in the North Sea, 50 miles away, and weather challenges that come, and we're all familiar with those from working offshore. And I guess the example for oil and gas facility, you're doing the same thing, but you've always got that resident platform. You've always got people out there. We probably will have an SOV out there in the field continuously, but we wouldn't have a permanent manned presence of any kind. So very different challenge to the one oil and gas has had. And I think this is a huge opportunity for us, as it's an area that we are very active in as the UK and in Scotland. And in fact, just this week, we visited the National Roboterium over here at Heriot Watts in Edinburgh, and very exciting to look at the opportunities that are out there for us to commercialise new technology, which is all part of the value case for being one of the first countries to promote and deliver commercial scale floating wind, which makes it ultimately so exciting. Just a quick word then on the sort of ports challenge, because I think that's another area where we're starting to see real movement. So we know that there's a need to upgrade and create new infrastructure to deliver this. It's been a challenge for a long time, and I've spoken on this on many occasions, if those of you have heard me, around the fact that you've got the chicken and egg problem. You can't take investment until you have projects. You can't get projects to FID unless you have the capacity and the facilities to deliver it. What we're seeing now is that is starting to crack. And that's partly because of Greenvolt securing its CFD and bringing forward the opportunity for investment, and indeed other projects, including fixed projects, finding use for facilities in Scotland to scale their ambitions. So it does look like quite an exciting opportunity, to be honest. And I think across the piece, we're very impressed to see the number of people looking at, investing in and around offshore wind in Scotland. And you might say even in the present climate, but there's very much a growing and opportunity-based climate as far as we can see. So I know Tim's going to touch on some of these topics. So I'm, rather than recycle any of that, perhaps it's a good time for me to hand over to Tim and let you talk a little bit about some of the challenges of industrialization, if that's okay.
First of all, just check that everyone can hear me okay. Just need one nod to
yeah.
Let me go on to presentation one. Yeah. So thanks very much, and thanks again to the AREG group for inviting us to talk this afternoon. I'm going to follow on a little bit from Alex's introduction and focus on floating wind industrialization, and in particular the evolving opportunity for substructure industrialization in the UK context. I should say I'm quite Presbyterian in my IT setup, so I have one small screen. So if anybody wants to ask any questions, please feel free to shout out. Otherwise, I won't know, and I will just keep going on. I think when you look at industrialization as an opportunity, you have to understand the scale of the prize for the industrial participants. And I'm sure we're all familiar with this map or a version of this map, and this almost sort of inconceivable long-term pipeline in Scotland, and potentially an even larger pipeline in the UK. So circa 25 gigawatts of floating and circa 20 gigawatts of fixed nominal capacity. Now, of course, there are huge uncertainties right now about how much of that will ever be developed, and also the timeline. But as Alex points out, I think there's very positive, first tentative steps to actually start to build up a kind of bankable pipeline for Scotland. And that's an enormous opportunity. And it really sort of reinforces the ambition and the desire for an industrialized approach to floating wind and the future of offshore wind. But on the other extreme, we have to recognize where we are today in terms of floating wind. Right now, the largest floating wind farm in the world is Hywind Tampen, which is 88 megawatts, 11 turbines. The largest grid-connected floating wind farm is still Kincardine, 50 megawatts, 5 turbines. So you still have this relatively micro-scale, technology-first approach, which is the state of the art, and this gargantuan opportunity. And we really believe that, you know, our project pipeline, we've highlighted Greenvolt and Senos, but I would also include Whitecross in that, really has a critical role to play in giving sort of the industrial space an understanding and a confidence in the feasibility of floating wind. And not just because of the timing of our projects and the high level of definition and certainty that they come with compared with many others, but also size is critical, and I'll discuss that in a little bit in the following slides. But you know, Greenvolt is not just a bellwether in terms of its pace, but it offers, you know, a factor of 10 increase in size compared to the kind of the existing incumbent T&D sites, and so it starts to introduce the concept of developing and demonstrating industrialization. And then, as Alex points out again, when you look at our Senos project, which follows on quite naturally from Greenvolt, that's another step up in gear and in scale, and really provides the stepping stones into this enormous opportunity for us all and for the UK. So floating wind as an industrial concept is really a kind of hybrid between many of the know-hows and the learnings and the technology from the oil and gas industry and from the bottom fixed offshore wind industry. And I use these 3 images to try and highlight some of those similarities and also some of the tensions. Anyone who's ever been to a presentation from me before has probably seen the same 3 images in the same story. For that, I apologize. But I think it tells quite an important series of messages by comparing these 3. The first thing is, of course, the 2 images on the left are real photographs, albeit taken 40 years apart. And they represent oil and gas and then bottom fixed offshore wind. The image on the right-hand side is a CGI image of a floating wind farm. And that's a non-trivial point, because one of the challenges that floating wind has is, you know, increasing confidence in supply chain to make the investments in people and facilities, increasing confidence in investors to invest in both projects and in supply chain, increased confidence of governments, and so on and so on. And on the one hand, these CGI images are fantastic at allowing us to embrace and visualize what floating wind could look like. On the other hand, they can pose a tension and a problem in, you know, managing expectations between where we actually are and, you know, what we might portray on a screen. As Alex mentioned, that, you know, oil and gas is characterized by, you know, a unit of 1, and you can very clearly see that in these 2 images where, you know, the left-hand image is an execution, I think, of the 40s jackets at NEG, and the right-hand image is the mobilization of the sea green jackets again at NEG, and you can clearly see, you know, one gargantuan jacket, the focal point at NEG, and on the right-hand side you can see numerous, I think, around about 50 at this stage in the project, jackets all lined up, and you can well imagine that the execution planning and the logistical planning and the delivery of those projects are consequently completely different, and the risks and the opportunities sit in very different places. The other interesting aspect of comparing these 2 sites, and it's interesting that these are the same sites, almost the same photographic angle, is, of course, in the heyday of oil and gas, the focus was on fabrication and on manufacture, and at that time, NEG was a thriving industrial manufacturing site, and, you know, they were busy building the jackets. In the middle picture, of course, the NEG site has transformed almost beyond recognition into a marshalling and staging post. And I think the first generation of offshore wind bottom fixed in the UK has really overlooked to a large extent that industrial opportunity. And it's very clear now from all sides that there is both a kind of an expectation and a need really to find ways to access the industrial opportunity. But you can clearly see here that these are jackets coming in from Middle East and from Asia and being marshalled. And, you know, really, like I say, the story of the UK and bottom fixed wind so far has been one of a staging post. And that's something we hope we can really change with floating wind. One last thing, which I think is interesting to point out about the photograph on the left, is these 2 ancient old Greek cruise ships that were brought in to alleviate the housing shortage because of the massive influx of workers to work on on the project at the time. I think these ships are quite notorious for all sorts of reasons, that probably for a different sort of podcast. However, I think they represent a couple of things that are really important when we talk about industrialization. First thing is that industrialization isn't just about technology and economics. It's about people and all the things that go with people. So that means houses and roads and infrastructure and schools. And the world 40 years ago is very different to the world today. So we need to think much more strategically and long term about how we make it reasonable and realistic and feasible for people to invest their lives in this industrial ambition. And the other thing that these two vessels always represent to me is a kind of a can-do spirit, which I think characterized the early years of oil and gas and is sorely needed to be transferred if we really are to access this kind of industrial opportunity in floating wind in the future. So this high level, very high level Gantt chart, be here for a couple of reasons. The first thing is to highlight maybe just the complexity of executing floating wind projects. And the reason floating wind projects are significantly more complex than bottom fixed projects is because of these long, highly interdependent critical paths that culminate in a couple of key nodes around energization of the turbine and around tow out of the assembled asset. Maybe the other thing to note is that actually this overall execution plan is really driven by the substructure. And I hesitate to say anything is standard yet in floating wind, but there's an increasing alignment around a concept where fabrication and assembly is fundamentally decoupled. So two very distinct work streams in this overall execution strategy, which brings opportunity for the UK, but actually brings additional complexities and considerations in this, in the management of execution. And linking back to our projects, and in particular Greenvolt, what you tend to find when you look at especially projects in the UK and in the North Sea, there's kind of a ceiling of circa 30 to 35 units. And in the small print, we should say, per vessel spread and per facility that you can install per year. And that's really just driven by weather windows and towing distances and towing speeds and so on. And of course, what that looks like in terms of capacity will grow as turbine size grows, but that is kind of a ceiling. And of course, conveniently, that does align very well with the kind of nominal size of the Greenvolt project. And it really just goes to show how Greenvolt can play such a pivotal role in becoming, I wouldn't say a pattern, because for sure following projects will want to challenge and improve upon the baseline that Greenvolt sets. But what Greenvolt will do is provide a first demonstration that industrial serial scale floating wind really is possible and how it can be possible, because then larger projects will just become multiples of that stock keeping unit that Greenvolt will demonstrate. So industrial ambition, I think, nearly every day, certainly every week in any of the press, both the general press and certainly press, whether that be offshore or offshore wind press, you see, latest announcements and allusions towards different aspects of industrialization for the UK. And there's no denying that there is, growing appetite for accessing the industrial opportunity in the UK. I think historically, going back to perhaps the first generation of bottom fixed projects, there has been a lot of, head scratching and angst that there was an over focus on direct cost, and that drove a lot of international manufacture, and lots of concerns around quote unquote local content. And it's quite refreshing to see at both regional and national level, and then sort of, let's say, UK PLC, the beginnings, but by no means the completion of a convergence around industrialization. And there's a couple of documents that I just thought were useful to highlight here. The first one on the left is the UK offshore wind industrial growth plan, where they clearly highlight the opportunity for substructures. And similarly, on the left, there's an offshore wind focus paper from late last year from the Scottish Government, where again, they clearly highlight the industrial opportunity in general and the opportunity around substructures. So you can start to see the mandate and the expectation being set that this isn't just about generating clean homegrown electrons, this is about generating value for the UK. And that's very welcome. I think anyone that has tried to navigate their way through the industrial growth plan will recognise that that's very much a first version of a document and needs a lot of work and iteration and development to become a really functional plan. But what I would say, to be glass half full, is that the best thing about this is the fact that it exists. And for a long time, there has been a real absence of this kind of industrial planning. So that's a very positive step. The other snippet, which I've put on the slide here, comes from Tim Peake, or Tim Pick. One's an astronaut and one's an offshore wind champion. His report from 2022, when he was the offshore wind champion. That's an excellent report. He made a really detailed study of the status of the offshore wind market and lots of clear recommendations, from consenting to technology to finance, and how the UK could access the enormous opportunity in offshore wind in general. But one of the things that he really emphasized is this question of make versus buy. And I've highlighted that here because I think when you talk about industrialization in a country like the UK, which is effectively a post-industrial country, we've lost a lot of the capability, like NIG of the 1970s, for example. We have to recognize that we can't, and we probably don't want to do everything. And so, we have this great, albeit evolving mandate, and there's clear logistical needs and rationale behind increasing our industrialization, our industrial footprint. But we also have to be realistic and sensible about when does it make sense and add value to actually build it here, and when would it just make more sense to access a global supply chain. The other thing about industrialization is, certainly in the early phases of projects, the developer is the kind of the owner of that challenge. And one of the aspects of that is how we align ourselves with all of the different stakeholders. And whilst there is this evolving mandate, with more clarity is welcome, but it's coming all the time. I think we have to recognize that sometimes it's quite a complex sell to our various stakeholders, whether they be financial stakeholders or whether they be partners, or perhaps most critically, some of our key contractor partners, how we demonstrate that doing large-scale execution in the UK is credible. And on the one hand, we see real tangible steps forward. Two, I think, to highlight from very recent events are, number one, the ongoing investment and physical construction and development at the Ardea, or I think what you could really call a megaport for offshore wind, and also very positive news that Navantia have acquired all of the Harland Wolff construction assets in the UK, and that will become effectively Navantia UK. But on the other hand, there are a number of previous attempts in earlier generations of offshore wind to do fabrication in the UK that didn't go so well, and then there are things like the ongoing ferry constructions in Port Glasgow, which do kind of fuel a certain amount of uncertainty and questioning of the rationale behind UK industrialization and UK fabrication capability. And I think it's important to recognize that, because development of projects is about bringing down risk and developing bankable, investable solutions. And that is something that we, along with all of the fabrication and construction partners, have to recognize and work on together. So technology selection, anyone that's been remotely involved in floating wind in the last 10 years plus will be familiar with the kind of diagram on the right-hand side, and a sort of smorgasbord of geometries. And there, quite rightly so, has been historically a lot of focus on what these geometries mean for performance and what they do and don't bring in terms of value. And they are, that kind of global sizing and layout design is extremely important in terms of loads generation and in terms of logistics, and perhaps most importantly on the interface with the wind turbine. And this sort of enormous sub-industry of technology providers, some of which are kind of startups, some of which are consultants, some of which are EPC contractors, has evolved, all with their own proprietary solution. And that's rapidly becoming quite a mature market. Where I think we see still a lot more room for technical development is on the right-hand side, and the technical development of the execution capability, because clearly for the UK to be credible as an industrial location, whatever that may look like, there's still some question marks about that. We need to evolve our industrial footprint and our industrial capability. And there's a few sort of leading photographs here. So there's an open question about how much fabrication versus assembly we do, and whether that's rolling of columns or panel lines and so on. Then putting in place the large critical assets to enable assembly and some of the other key steps clearly needs a very well-defined business case and a level of certainty for the supply chain. And then, of course, there's just the very fundamental question of availability of skills and labour. The economy in the UK has evolved massively since we had, things like NIG and Ardasir and methyl and so on, operating. We don't necessarily have the skill base, and there's an open question whether we really want that skill base. So we have to decide how much emphasis we want to put on training versus how much we want to, and then therefore growing a headcount and the associated value and cost with that versus how much do we want to optimize and really use technology to leverage industrialization. And I'm posing these as kind of open questions because I think we, from our slightly privileged vantage point, we can begin to see a trajectory, and I think there's a reasonable amount of alignment between sensible developers and the supply chain. But equally, you can imagine that a lot of these discussions have quite a proprietary element and also have a kind of regional tension element. So some areas may prefer to really focus on recruitment, and some technology providers may really prefer to focus on assembly speed over numbers of people involved in the construction of the project, and others may prefer to just absolutely optimize cost. And that's inevitable as the market grows. And in the kind of summary, I'll try and illustrate what that might mean for the different options for industrialization. So I think if you were to ask 5 floating windologists, you'd probably get 10 answers in terms of how you might execute projects. Although, as I say, there is, we are beginning to see a bit of convergence. I tried to pull out 3 high-level types of scenario that are still very much on the table, and I'll try and give a little bit of context about what these might mean, as well as, and from a technical point of view, as well as what they might mean from the UK from a sort of value extraction point of view. Maybe technically, first of all, on the left-hand side, you have the classic shipyard approach, and I think this is Kincardine being constructed in Spain, where you start at a single location, you do all the fabrication in a series of fab shops, you bring the components together, and you assemble them into the hull. That's a tried and tested method. There are lots of places around the world you can do that. We used to have that in the UK, not so much anymore. The latest generation of floating wind projects, so for example, the 2 most recent projects to go in the water in France, which is Provence Grand Large and EFGL, which I will not try to remember what the acronym stands for, both use this kind of modular approach. And I think modular has become a bit of a buzzword, but perhaps needs a bit more explanation, where the components were sourced from effectively a global supply chain from various yards and various facilities with different specializations. And then they were brought to a local assembly hub, but they were then assembled using pretty conventional techniques. So quite a lot of added content, but a kind of a balance between global supply chains and bringing value in country. And then, of course, there are a growing number of quite proprietary technologies, all of which focus on basically allowing local assembly in post-industrial countries. So trying to take a lot of the high skill requirement out of the assembly process. And they have their own sets of pros and cons, but of course, I think a key feature that you have to recognize of those is that for the moment, at least, they are tied to quite specific technologies. So what I tried to illustrate here was just how the different pluses and minuses of those might wash out. I mean, first of all, if you think about the shipyard potential option, there's of course an enormous question mark about just the basic feasibility of it. Do we have this? Do we have the space, and would we ever be able to, as a country, fund that cost base? Leaving that aside for a second, it is interesting because actually, if you were to, of course, the value to the UK would be enormous because you would have a huge number of UK people and UK embedded companies put value back into the UK. On the flip side, your speed would become extremely low because this is not an efficient way of delivering units because you're using your resources across the full manufacturing requirement of the floater, and you end up in this very slow, laborious process. From a jobs and a skills point of view, potentially extremely attractive because, of course, you need a large number of people. But I think whilst we do have first signs of an industrial strategy, it's not yet clear how we want to compete between industries and where and how we want to assign resources. So it could be that actually this approach may just swallow up too much of the UK fabrication capability, even if it was a great opportunity for employment. The modular assembly, on the other hand is perhaps more of an attractive compromise, because on the one hand, you leverage the benefits of established, mature methods. That being said, of course, the logistics around this are not yet mature. And when you multiply the complexity of shipping, let's say 10 components times 100 units over a 2 or a 3 year construction campaign, you can imagine that managing those critical flows and having enough stock and tolerance stacks and so on, and managing, let's say, half a dozen different feeder yards into your assembly yard across what's basically a global supply chain does have a lot of complexity that will need to be evolved. But what it does do is it does allow your speed to be increased. And I think, interestingly, you still have an opportunity to capture quite significant UK value. And in terms of jobs and skills, yes, maybe not quite the enormous number of jobs and skills that you might capture from the, let's call it, the shipyard approach, but I would say quite a significant number, certainly from the work that we have seen on different options. And then there's the kind of the long-term opportunity cases where you have the opportunity both to kind of optimize structure and to take complexity, quote unquote, out of the assembly process. Now, really what they drive is an ability to, or a potential ability to maximize the speed of execution. But I think it has to be recognized that potentially you do that at the expense of the numbers and the types of the skill base that you are giving the opportunity to cultivate, and also the amount of value that you're delivering in country. And so I would emphasize, I think all of these opportunities are being considered by different groups, and to some extent they're still on the table. And perhaps before I move on to my summary slide, I think it's worth mentioning that whilst there are some very positive first steps towards having a plan and a strategy for the UK, if anyone was to read those documents or any of the other probably dozen documents in a similar vein, you could use them to justify any one of these approaches. So clearly there's still a level of alignment and refinement, both from the supply chain and from the kind of the UK PLC pool needed. Maybe a couple of things just to summarize. The first one that I think we would always emphasize as flotation, and it's a very non-trivial message, which is floating wind is real. You know, there's clearly lots of a very dynamic market in energy right now, and lots of confusing and conflicting messages, and a lot of uncertainty around floating for various reasons. However, flotation has clearly demonstrated not just that floating works, that floating can work repeatedly, and the ability to scale up and bring very credible partners, like, for example, TEPCO, along on the journey. And that really is a number one extremely important message. I think the second message is probably that, you know, very refreshingly in the UK, ambition is clear, and it's becoming clearer all the time in terms of what is expected by overall value capture from floating wind. However, how that's going to be delivered is not. And I think, you know, Alex touched on it earlier, but there is a need for a more refined, let's say, UK pipeline and more alignment on what a UK supply chain could look like. And really that needs to happen before we can have a clear view on that make versus buy question, and how we will deliver technology in a sort of UK industrialization context. And lastly, and perhaps a little bit uncertainly, but I think very realistically, there is unfortunately no right answer. It's very easy to reflect, and perhaps I did it at the beginning too, on the first generation of offshore wind projects, and roll your eyes a little bit about the lack of UK involvement and engagement, and turn the UK into a kind of a staging post. But equally, I think the developers in those projects were, you know, set a certain mission, a certain task, and a certain set of boundary conditions, and they have all done their best to deliver projects within that. Clearly, the mood and the appetite and the focus is changing along with some of the technical requirements. And that means we may well take a different approach. But I think it's realistic to think that will evolve again in the future. So that's it from me. Very glad to answer any questions, or to have follow-up discussions with anyone. I'll stop sharing my screen now because I couldn't see if there are any questions. I'm glad to see you're all still here. That's a positive start.
Thank you both.
Sarah, do you want me to just run through the questions in the chat that we can see?
Yeah, if you can, and if anyone else has any questions they'd like to raise their hands for, please do feel free.
Yeah, I mean, there was a couple of questions in here about contacting the supply chain. I think it's great to see folks in contact with supply chain colleagues already in flotation. That's without doubt the best way to be in touch. If you're not sure how to reach them, then a very good way to do it. The Green Vault website certainly has contact details, and there's a website address, hello@greenvault offshore wind. I assure you it's not just discarded to some call center somewhere. It is read by people and actioned. So reach out there if you're not sure how else to do it. Or indeed, the Flotation Energy website also has contact details. If you're struggling, I'm quite happy to direct queries from you, and you can either get my email address or just ping me a LinkedIn, and we'll try and do it that way. To get a couple of more technical questions with O&M, Paul from Intelligent Plant. I think the O&M piece is a big part of what we want to bring to the table. Clearly, things like turbines tend to come with their own warranty period, and that's a standard way of doing things in the offshore wind industry, and we would probably expect to do that, but that's usually for a time limited period, and then beyond that it falls back to the operator. Of course, the maintenance and management of the rest of the structures, the moorings, the electrical system, and all of those things remains as it does with fixed wind with the operator, and it's a huge undertaking, and actually it's a huge value stream, and it's something we're very well positioned in Aberdeen and in the surrounding area to support. So very excited by that opportunity for us and for our local supply chain as well. I see a note similarly about digital twins. I can only expect that that's what we will be doing. We know there's a lot of opportunity in that space these days, and indeed coupling with AI, there's a potential for almost self-diagnostics in that space. That's something I'm looking at, and it's part of, again, that automation challenge. So happy to pick that up elsewhere. And I think I've kind of covered some of the points around O&M responsibilities. I think that's a quick wash up, Sarah. I realise we're out of time, and deep apologies for not being able to take more questions here. Back to you, Sarah.
Yeah, no, thank you both Tim and Alex. And Alex, thanks for sort of running through the questions quickly. If anyone has any follow-up questions, I'm sure we can kind of pass them along to the speakers, and we can put people in touch if that's okay as well. But yeah, I think that concludes today's session. Once we've finalised everything with slides, we'll be able to share them and today's presentation recording as well. We'll also share a feedback form, so any further questions with that or suggestions for future events, topics, anything, we're always kind of open ears to hearing your suggestions and integrating what we can do to sort of cover topics that our members really want to see. Just a final reminder of the Scottish Energy Futures Conference next week. There are still tickets available, so please do sign up and get involved if you can. A really exciting couple of days and some insights from some of the most innovative companies driving the clean energy sector. So a really important event and interesting one not to miss. So yeah, no, a final massive thank you to both Alexander and Tim for your insights and everyone else in the background in Flotation for helping getting everything set up. It's really been interesting to hear more about the exciting projects, you know, particularly Green Vault, and you know, a real sort of positive catalyst for the Scottish floating wind industry. So thank you everyone for the engagement. Hope to catch up with some of you at the conference next week. As I say, if anyone has any questions, please do get in touch, and I'm sure we can forward along any further questions for Alexander and Tim down the line. But yeah, thanks everyone. Bye for now.
Thank you very much for your time.